Hey, my name is Jaegon Lee, and this is my ENME351 Lab 9 project. So for my mechatronic system, I made a solar panel light tracking device, which basically aims to sense where the light output is above the solar panel, and then change the angle of it to face that light source head on. So for my sensing component, I have two photoresistors, one on each side of the solar panel. My actuating component is the servo to change the angle. And both of my 3D printing components are the servo mount, which helps prevent that jerking motion as the servo is actuated, and the solar panel itself, which is attached to the servo arm, which has each photoresistor on each end. So a quick rundown of how this works. The photoresistor basically changes resistance value based on the light that it's sensing. So if a light is sensing on it, it'll read a low resistance. If it's dark, it'll read a high resistance. And using that, we can basically convert that to a voltage value that the Arduino can read by connecting each photoresistor in series with a regular resistor, which is 10K ohms, and then reading the voltage drop across them. So using the voltage drops, we can determine the difference between them on either side. And then using that difference, we know whether to rotate it left or right or to stay still. For example, if the light is flashed on the right side, we know that the voltage drop across the right side will be greater. Therefore, the difference would be positive or negative depending on which side. And then we know the servo has to actuate towards that side until they're balanced, or AKA the difference would be around 0. And that threshold is something we determine using Arduino. Quick demonstration. As you can see, it's already rotating towards the window. I'll be using a flashlight to demonstrate a light source. And as you can see, it's following where the light source is. And it stops when both resistor values or photoresistor values are around the same. And for my processing component, I basically have an oscilloscope reading of both the left and right photoresistor, as well as the difference between them. Important note, for the difference, we can see that the 0 line is around 2.5, where the servo isn't moving, so that means it should be balanced. That's because I created a fake ground line at 2.5, so the voltage or the difference voltage reading doesn't dip below 0 and become negative or positive depending on whether or not left or right is greater. This is just to evenly align all the readings to be in a nice condensed oscilloscope instead of having the blue line dipping below and above 0. And as well as that, I have two sliders to determine the threshold of what the balance has to be, or the sensitivity reading has to be on both photoresistors. If the threshold is greater, that means the difference has to be greater for actuation to happen. If it's lower, that means it'll be more sensitive to light input, so it'll probably jitter a lot. And the right determines the speed, which is basically done by increasing or decreasing the duty cycle in the PWM function of the servo, since we can't use the servo library. So I'll demonstrate that. At a high threshold, as you can see, it's not very sensitive to it unless I'm very close, because the difference has to be greater. However, at a very low threshold, let's say around 10, it'll be very sensitive. Even if my flashlight is quite high, it can accurately read and track where the light source is coming from. And similarly, the speed, right now that was at 5, which is the default. If I make it 15, then it'll be very fast because the PWM duty cycle is that much greater. And yeah, it's very fast, as you can see. And yeah, that's my final project. Thank you.